Good morning, ladies and gentlemen, and welcome to the CSIR conference that is hosted by the CSIR. Discussion focusing on the industrialization of additive manufacturing towards the revival of the manufacturing industry. I would also like to thank our panel members for availing themselves this morning. So throughout the manufacturing revolutions, starting from the 1970s, the 1780s, where you had steam or coal-controlled and simple mechanism, and in the 1870s, then there came electricity, which now allowed for mass production and also the mass production in assembly lines. And then in 1969, there came the third manufacturing revolution, as it's called, where you had more computer-aided or robots now working to supplement some of the work that was manually done, and also that allowed for the production facilities to run for 24 hours at a time. So today, we are looking at our fourth manufacturing revolution, which focuses on the Internet of Things, additive manufacturing, data science, and so on and so forth. So the CSIR, when we were busy coming up with a strategy for Project Synapse, one of the things that was realized is how do you now integrate all these 4IR technologies into a demonstrator, which is a research factory that is shown now on your screen. And there's the research factory, or the smart factories as they are called, will have smart sensors throughout the factories. There will be robotics that are integrated into the systems. You'll also have industrial analytics, automation, and additive manufacturing or 3D printing, which is what the focus for today's presentation is going to be about. So what is additive manufacturing? Additive manufacturing, according to ASTM, it is the process of joining two materials to make parts from a 3D model, and it's usually done using a layer upon layer process as opposed to subtractive manufacturing that is currently being used today. And there's different materials that can actually be accommodated with additive manufacturing, ranging from metals, polymers, ceramics, and metal matrix composites. So because this is a melting or sintering process, one needs to also have a power source, and currently you have a laser and electron beam as a power source. So with any production, one has to look at the full value chain. So additive manufacturing starts with a design, where a CAD model design is created, and there's also presentations on design for additive manufacturing, because design for additive manufacturing is different from design for subtractive manufacturing. And then one has to focus now to look also at the different materials that can be used. So at the CSIR currently, we are focusing on titanium alloys. We have aluminum alloys, steel, nickel super alloys, and titanium aluminides. And then the third part is the actual printing, 3D printing or additive manufacturing, when now one looks at the machines that are currently available, the capabilities of the machines, and what the requirements are for the 3D printing of the part. After printing the part, because additive manufacturing is an near-net shaped process, due to the melting process, you find that you do have rough surfaces sometimes which are not ideal for different applications, or you have properties that are not ideal, and you also have residual stresses that are built in due to the heating and cooling process. So then we have a post-processing, where the focus will be on heat treatment, surface modifications for you to get the ideal properties that you're actually looking for. And in order for the part to be used in application, one has to keep in mind the requirements for different industries, such as the aerospace, rail, mining, and automotive industries, which have different requirements in terms of the specification, the inspection, and their testing capabilities. So South Africa has been active in additive manufacturing for quite a while now, and this has been mostly funded through the Department of Science and Technology, now the Department of Science and Innovation. And looking at the general landscape, you have the CSIR, which focuses on metal additive manufacturing. We also do platform building and part manufacturing, and we do infrastructure refurbishment. The CSIR and Aerosuit came together to collaborate on a project called the AeroSwift. The project is a high-speed, large area metal AM machine that is housed at the CSIR, focusing mainly on aerospace alloys. You also have the Vaal University of Technology that is working on mainly polymers and tooling. You have the Northwest University focusing on the design for additive manufacturing, but also looking at the safety of the metal powders that we are using, and bioprinting of different organisms. Central University of Technology, where they're doing metal and non-metal additive manufacturing, and also focusing on medical implants and tooling and just general manufacturing. You have Stellenbosch University, also working on tooling design and improvement. And we recently have a company that was formed in 2015, 2016, Metalhead in Johannesburg, that has procured commercial machines to provide the tooling industry a service in additive manufacturing. So most of these platforms that are housed at the various institutions that I've just shown now are commercial systems that are procured internationally in Germany mostly. And one of the main supplier of additive manufacturing systems now, or 3D printers, is SLM Solutions in Germany. They have a maximum size of about 500 millimeters, and it can accommodate any metal powder. The second system is EOS, also based in Germany, and they have a powder bed maximum of about 400 by 400. But the problem, or the drawback with the EOS system is that it's specific to a certain metal powder, so one cannot explore any other metal powder except from a specific manufacturer. So, and the two systems that I've just shown now are actually powder bed systems. So at the CSIR, we have a commercial system called the Lens. This is the laser engineered net shape system that we procured from the US. It's a system that can accommodate quite larger parts. It also uses any metal powder, but it's a 5-axis system, so it doesn't allow for the complexity that is attractive to additive manufacturing that powder bed systems actually offers. So based on that, then the CSIR, together with Aerosuit in the first system on your left, which is the AeroSwift system, where it's a system that accommodates metal powder, and currently it's at TRL level 7. So we have also built a second prototype system at the CSIR, which is 400 millimeters by the size, and it can accommodate any metal powder. It's currently running aluminum powders, and it's a prototype system at TRL level 7. So the capabilities that were built then at the CSIR based on building these two systems are the ability to custom make these machines. We can exchange powders easily. We have design and simulation capabilities. We can do process monitoring, and most importantly, we can also do, we have focused on human capital development and skills transfer. So I'm going to go quickly to the slides now. My time is running out. So in one of the projects that we undertook with the Department of Science and Innovation under the CPAM project was to look at how additive manufacturing can be integrated within a manufacturing system. So this starts with firstly identifying parts, also developing comparative design models, like I mentioned, design for additive manufacturing, and implementing a business case or a business plan, which goes all the way from quality, cost savings, to a detailed implementation plan, detailed supply chain plan, with the final aim of having market implementation through distribution of products and services. So then we did a short survey with a company here in South Africa where we used this criteria, but the criteria I'm going to be presenting on now is on the internal organizational readiness, looking at the resources, the organizational backing, and if there is fit for manufacturing supply chain distribution within the organization. So the survey, in general, it showed that there was quite a lot of interest in additive manufacturing, where we scaled it from very low to very high, what the feeling was. In terms of organizational buy-in, you can see that most of the employees looked at this as an in-house possibility within their own facilities. And then in terms of the organizational benefit also, there was market penetration that the company employees realized that the system can actually, the additive manufacturing can actually be applied on. But in looking at how this system can be integrated, most of the employees saw that this as a standalone system and not as a system that can be integrated within their manufacturing facilities. So I'm going to quickly go through some of the slides just to give some case studies. So for the aerospace studies, you have companies such as Airbus, GE, Boeing, and Aerospace that has made quite a lot of investments in additive manufacturing, where they see medium to long-term benefits. And because additive manufacturing is a powder-based system where you can recycle the powder as many times as that can be allowed, you have a decrease in the cost of the parts, and also a decrease in the time to market, and a buy-to-fly ratio of 1:1, with also looking at the beneficiation of the minerals. So this is just a picture of some of the parts that have been earmarked for 3D printing within some of these companies. For the rail industry, Siemens has developed or come up with an additive manufacturing experience center that is based in Germany. So what they do is that they do the 3D printing of rail rolling stock, which allows for the fast production of the tools and 3D printing on site at any time. And also it provides for optimization of the spare parts with a higher benefit and lower costs compared to when one has to rely on an external supplier, and these parts can be readily available. Parker Hannifin is also another rail manufacturing company that is based in Ohio, where they also have an advanced manufacturing learning and development center, where they're looking to accelerate innovation in additive manufacturing through product design and part production. The automotive industry. Volkswagen is one company that actually uses additive manufacturing, not necessarily for structural parts, but they use additive manufacturing within their production facilities, where you can build parts, tools, jigs, and fixtures that are needed at different times. And through this project, they realized a return on investment of about 150,000 euros, and also 100% return on investment within 2 months of implementing additive manufacturing within their facilities. Just below here is just pictures from some of the work that's been done within the automotive industry, where OD, together with SLM Solutions, had a collaborative project where they were 3D printing the water metal connectors. And the second one is EOS, and REN Team University of Stuttgart, where there is a Formula One student racing competition every year in Germany. And the student had to optimize the design for the axle pivot, and they ended up with 35% part saving with the additive manufacturing. That led to now less fuel consumption, so they could do more laps and refueling within the laps, and the student ended up winning the competition for that year. So Porsche is also another company that is now looking at 3D printing of legacy parts, where you have classic models of cars where the parts are no longer in production. So those cars are able now to be serviced due to the availability of 3D printing. The mining case study is an interesting one, because there's a company in Australia, Additive Now, that together with Aurora is also a 3D printing supplier, where they came together to see that there was a need to print on site of parts within the mining industry, and because most of the mines are in remote areas and difficult to reach areas. And this will allow for the redesign and prototyping of not only new parts, but also reverse engineering of parts, of legacy parts on site. And some of the examples of the parts that are being targeted for 3D printing in this case in the mining industry, it's your mining pumps, magnetic pumps, drive pumps, and so on, and also the impellers that goes within these pumps. So the last case I'm going to present, it's a local business, Metalhead. I mentioned it a little bit earlier, where they do 3D printing of tooling components, such as dies for casting. And they do this with the 2 machines that they procured from SLM Solutions, dedicated specifically for titanium and aluminum parts. Now, Metalhead also has an agreement with Stanley Black Decker South Africa, where they manufacture industrial tools for household hardware and also provide security products around South Africa. So that then concludes their presentation, and we will now move over to the panel discussion, where I will firstly introduce the panel that is joining us today. I think I'll shift to the side a bit. Yeah. So on our panel today, we have Ms. Ntombi Marule. Ntombi Marule is a Director of Innovation and Technology Policy and Strategy at the Department of Trade, Industry and Competition, and she holds a BSc degree in Chemistry and Applied Chemistry and a Master of Management degree in Innovation Study. She is responsible for the development and strategies, as well as introduction of new incentive and support instruments for technology development, commercialization, and innovation for the promotion of enterprise, competitiveness, and industrialization. She previously worked at the Department of Science and Innovation as a Deputy Director for Emerging Research Area, where she was responsible for the implementation of the National Nanotechnology Strategy and the development of the National Strategy for Photonics. Prior to joining the DSI, she was part of the Radio Analytical Scientist team at NEXA for more than 6 years. She is currently serving as a board member for the CUT, Central University of Technology Innovation Services, and a chairperson of committees of Finance, Planning, Sustainability Committee of CUT. Our second panelist is Mr. J.P. Serpfontein, who is a Senior Research and Development Engineer at Aerospace. JP has 12 years of experience in the design, manufacturing, qualification, and certification of aircraft structures. He started his career at Denel Structures in 2008, where he worked on the Airbus A400M program as the member of the stress department composite team. In 2012, JP joined Aerosuit Aviation. He formed part of the engineering department conducting stress management and product qualification. In 2015, he started his career in additive manufacturing. JP completed a design for optimization study for which 2 design philosophies were created, biomimetic and prismatic AM components. In 2017, he led an engineer in the Hyper-Joint Research Project, which focused on the in-situ forming of AM manufactured components for carbon fiber reinforced thermoplastic. He is currently working on a collaborative research program with Netherlands Aerospace Center, NRL, which is pioneering the design for certification of AM aerospace components and its adoption in commercial aircrafts. Our third panelist member is Professor Kumbulanimbovu. Professor Bofo is a professor of industrial engineering at the Faculty of Engineering and Built Environment at the Tshwane University of Technology. He is also a Gibela Research Chair in Manufacturing and Skills Development, a founder of RMCE RA Incubator, Mercita Chair in Intelligent Manufacturing, DST NRF SA Chair in Future Transport Manufacturing Technologies. Kumbulani is an established NRL-rated researcher with an unstoppable appetite for industrialization in his activities, who has graduated over 5 doctoral and 20 master's students in the last 10 years. In the past year, he published in excess 30 journals, more than 75 conference papers, 10 book chapters, and 4 patents to date have been published and registered respectively. Over 30 presentations at conferences, guest lectures locally, regionally, continentally, and internationally have been given. He has also been recognized 6 times at the National Awards NSTF, South Africa Institute of Industrial Engineers, and the Standard Bank Rising Stars, and more than 5 times in the University of Research Excellence since the beginning of his career. To date, he has been awarded funding of over 50 million rands for research, innovation, incubation, and commercialization activities. Our next panelist is Dr. Silatla Chigosha. She's a senior researcher at the CSIR. Dr. Silatla Chigosha is a metallurgical engineer with a BSc engineering qualification from the University of Zimbabwe and a PhD from the University of Cape Town. She has 10 years experience in process and product development from Element 6 and the CSIR. Her expertise includes knowledge of various powder technologies such as direct powder rolling, spark plasma, sintering, additive manufacturing, press, and sinter. She specializes in product development of several materials ranging from ceramics, light metals, precious metals groups for various applications and industries. She holds patents, technology demonstrators, and products such as titanium sheets, billets, irregular, and spherical powder for her work. She was a nominee for the prestigious NSTF TW Kambule Award for Research with 6 to 15 years of experience. So we had another panelist who unfortunately could not join us today, Mr. Brian Monakadi, who is a general manager of capital planning at Transnet Rail and the global chairman for International Heavy Haul Association. So we are now going to go into part of the discussion where there are specific questions that were posed to the different panel members, and we'll start off with you, Prof Bofo. Can you hear us?
Hello, can you hear me?
Yes, we can hear you, Prof. Thank you very much for joining us this morning.
Yes, thank you very much for inviting me. It's a pleasure for me to participate and also express the legal findings that we have come across in our research.
Okay, so the question that is posed now to you is, as someone who is in academia, what role do you see academia playing in the generation and dissemination of knowledge to ensure that such technologies are implemented in industry?
Thank you very much for that question. How many minutes do I have to respond? Because I can present an hour's paper.
Okay, you have 2 minutes to respond.
Okay, so let's see what I can do in 2 minutes. So I think definitely there's a part that academics must play in terms of education. I think the role of education is a critical one if we're going to build up this capability in the country and utilize it extensively, as you've indicated, the case studies that we have been demonstrated. If there are no institutions that are offering even an official qualification around this, I think it's a matter of agency that in terms of all these new HUQSF recalculations that are taking place, the Department of Science, now that they are linked with the Department of Higher Education and Training, deliberately make an effort at all levels, even at TVETs, to make sure that there are qualifications around additive manufacturing, because there is no going backwards with this technology. And then secondly, I think, I mean, if there are other questions, I've got more detail that I'm willing to share. But in the 2 minutes, I will speak to the 3 points in general that I want to express. The second one is taking part in research aimed at developing the necessary tools required for additive manufacturing implementation in industry. So if these processes are not being utilized for beneficiation of our vast mineral resources, we are not doing the country a favor, neither are we doing the continent, neither are we doing the general global south a favor. So I think for me, there needs to be efforts with the Department of Trade and Industry coming together, supporting infrastructure projects that are seeking to research ways in which additive manufacturing can be used in industries. Right now, we've got a project going on with Mesita on component localization, and there are various components that we've been identifying that need to be produced locally. And some of those components speak to the additive capability. And I think there's space there. I think the other thing is partnerships. The chairperson of the board of CSIR, Professor Majosi, wrote a paper recently with Professor Marwala, the vice chair of the Presidential Commission on the Fourth Industrial Revolution, on this topic, indicating that it's important for us to invest in R&D, which is associated with the, which has an indirect relationship with the giving of social grants. And And if we lose that opportunity, I think there's a big problem. So once again, education. Secondly, intensive research that is industry focused, that is not blue sky. And of course, the aspect around partnerships, because without partnerships, we cannot be able to take this technology forward. Thank you, host. I don't know if I'm clear or there's questions.
Yes, you are. Thank you very much, Prof. You speak on beneficiation, and it's one of the panelist members, Leitu, who is working on metal powder. So I'll pose the questions to her now to say, one cannot talk about additive manufacturing without taking into account the metal powder. So currently there are most of the metal powders that we're using, we are exporting internationally. So what programs are there at the CSIR and within the wider South African powder manufacturing industry to develop powders that are suitable for additive manufacturing?
Thank you, Chair, and thank you for this opportunity to come talk to you about the work that we do in developing spherical powders for additive manufacturing. And as you have mentioned, in terms of spherical powder production, we do not have a lot that is going on in South Africa in terms of commercialized products that are manufactured within South Africa. We do, however, have a few people who've played around in the labs and done some work to demonstrate what could be potentially be done with spherical powders and AM, and that is Sibanye Stillwater with PGMs, which is your precious platinum group metals, and then you have got Mintech, who've played around with your low melting, non-oxidizing metals to get to spherical powder. And then we've got Nexa as well, who is really doing quite a bit of R&D on spheroidization of quite a number of materials, quite a range that can be used in different applications. Specifically now with the CSIR, what we are doing, most of the work we've done over the years has been under the DSI titanium beneficiation program. And part of what we had to do was to develop titanium and titanium alloy spherical powders. And during the course of that project, we did do quite a number of processes. We came up with several different processes that can be used to make spherical powders, one of them being billets that we could convert by atomization to make spherical powder. And then the other one was the taking irregular powders and spheroidizing them and turning them into spherical powder. And during the course of that process, we also set up a facility, a powder testing facility that is accredited, and it uses standard, internationally recognized standards to actually do the test for composition, for properties, to make sure that these powders that we produce can flow within the AM machines that you have, several of them. We've created partnerships specifically with NLC here, where we've taken some of the powders to test them if they can work for additive manufacturing. And we've also gone on to set up a mechanical testing lab that is also ISO accredited. And in this lab, we can now test the products that come out from the powders we make, the components we do by AM, and finally, what is the structure property relationships that we get out of that. At the moment, the focus is moving from the development to commercialization. And in order to do that, we have to secure and localize the process of making these powders. And we are looking into procuring the atomization or the spheroidization equipment and setting it up at the CSIR. We want this equipment to be the one that is versatile and to be of scale, that it can be used either for development or for somebody to start breaking into the market and commercialize different products. So what is available is that we are looking into partnerships where we can incubate, where we can do joint ventures, where we can also do SPVs to allow for the commercialization of all the spherical powders that we develop within the CSIR. And furthermore, want to create this as a one-stop shop that will continue to support the companies that spin out and start to commercialize the powders, but also to start to develop other materials other than titanium, as she has mentioned, that we can do aluminum alloys, we can do steels, we can do super alloys, and we want to continue to build on that capacity, and then we transfer it, and it becomes a continuous cycle that allows us to now be able to support the AM industry.
Okay. Thank you very much, Dr. Chigosha, for that response, and especially because, within the CSIR itself, there is quite a strong collaboration with the research group that is doing the powder and the research group that is doing additive manufacturing, as we are the users of the metal powder. So the next question goes to Mr. J.P. Serfontaine. Aerosuit, I've mentioned earlier that we do have a collaboration with Aerosuit on the Aeroswift program. But aside from the Aeroswift program, how do you envisage the integration of additive manufacturing within your manufacturing facility as a company that provides components or parts for original equipment manufacturers globally?
Thank you, Chair, for the introduction and having me part of the panel. Your question is well suited and is a difficult one to answer in the long term. So if we look at AM as a standalone, obviously that is not a feasible option. So for Aerosuit, it would form part of the existing infrastructure that we have, where we have machining capabilities, forming capabilities, and so forth. So AM would essentially integrate into an existing infrastructure where we would manufacture components on demand by said customers. So the other point being, should it be used as an in-house capability or a bought-out item where we would rely on suppliers such as Metalhead to supply us with the end product, where we would then do the final post processing of the components. So long term, it is a wait as such for our customers to decide when AM will eventually be integrated successfully into aircraft. At this stage, we know that what comes out of additive manufacturing in terms of metals, uncertainties still lie in terms of the actual reliability and consistency in the build. Microstructures are affected by the heating process or the melting process. And until we get a consistent build and a reliability in what comes out of the machine every time, that would then lead to the point where aerospace would have a successful adoption of components. So at this stage, your class 1 and your class 2 non-structural components will be useful, but it's still not feasible given the price of what a machine would cost, or a component for that matter. This is why we are collaborating with the NLR. They are leading the investigations into metal AM on LPBF and DED perspectives, and how we can leverage that collaboration to get to a point where we will see certifiable components that would then lead to, in our view, the integration process starting to take effect. As aerospace is a highly regulated industry, it's a very costly exercise to certify what AM is required to meet, which is you have to certify the powder, you have to certify the machine, you have to certify the process, and then you finally get to certify the part. So in the long term, a single machine may only produce a single component or a batch set of set components overall. So that integration, again, it lies within the long-term vision of the aerospace OEMs, and how they will start introducing those components where the return on investment starts to make sense, and we can successfully and reliably certify our components.
Thank you very much, JP, for the response. I think our time is going to run out, so I'm going to go to our next panelist, Ms. Ntombi Marule. So, looking at the Black Industrialist Program and New Industries Initiative within your department, and based on the conversation today, how can SMMEs benefit from such programs to ensure that additive manufacturing is widely used in industrial application for machine manufacturing and as a service provider, using locally built technologies such as those that we've showcased from the CSIR, such as the Aerospace and the other systems?
Okay, thank you so much, Ntombi, and thank you for having me as one of the panelists today. I'm actually very excited. And as I'm sitting here, I'm thinking, I'm in the midst of engineers, doctors, you know, you're talking the, the language that is so complex for me, but I think I like the question that you asked, because for me, you know, when I was invited and when I got the invitation for the first time and I was sent the questions to answer, I thought of how we are currently consuming music. You know, so in our times when I was growing up, we would buy CDs and records and things like that. But now you go to Spotify, you go to Spotify and then you get the particular song that you want at the particular time. And you just pay a minimum subscription of like 70 rands per month. And I want to juxtapose this with the, you know, additive manufacturing stances and how we need to think about our industries, because we need to think of it exactly like that. The time for us to have very large industrial, you know, spaces where you get this number of machines and everything happening at one space. I kind of feel like with the fourth industrial revolution, that is something that should be on our rearview mirror, which means then we need to think very differently about how we want to create these new industries. And I like the fact that you brought in the SMMEs, you brought in the new industries component, and how the Black industrialist can really function in this space. How you link in this space then research and industrialization talks to how then your knowledge transfer strategies, even from the CSIR, are then optimized to make sure that that knowledge lands onto the SMME for them to then run their businesses. Dr. Chigosha earlier on was talking about the fact that we are preparing, CSIR is preparing an environment that's going to be able to support. But for me, I would have wanted CSIR to look back and say, who is in the environment and what do we do for specific people, such that then it's not about just demonstration of capabilities, but it's about strategic and deliberate activities that are geared towards a production of a specific company, of specific industries, and of specific SMMEs for starters. And then how then Black industrialist programs come in. Earlier on when you did your presentation, Ntombi, you talked about how, you know, tooling, especially in how now we are getting all these instruments from Germany and everywhere. Our then focus should be on how then do we create these SLM solutions in South Africa? How do we create an IOS in South Africa and have a strategy that then talks to that? It doesn't necessarily have to be a Black industrialist program that can support that, but it can. But then how do we then make sure that even when we talk about a machine manufacturing, it's something that we can create in-house? If we talk about localization and import replacement, this is where now you breed SMMEs that are technological, that are strategic, that are productive, that then we fund through your new industries agenda or new industries funding streams that the IDC is driving. So for me, I think in a way, we really need to think differently about what is the new industry of the future. You know, recently I was reading a piece that was produced by Frost and Sullivan. In this piece, they were talking about unleashing the new wave of growth strategies, and they were looking at how, you know, the chemicals industries and materials industries are being disrupted by this new the fourth industrial revolution. And they were saying, you know, we need to go into those lean manufacturing and very strategic and narrow. Gone are the times when you have a company that produces everything. You need now to have a company that just specializes in nuts and bolts and makes that their main bread and butter. I don't know if this makes sense, but that would be my contribution to the conversation. Thank you, Ntombi.
Yeah. For your contribution, and you know, yesterday there was a panel discussion, one of the plenary sessions where our CEO, Dr. Dlamini, was also there, and it was emphasized, you know, the skills development, to say without the relevant skills, as South Africa, we won't be able to actually reap the benefits of 4IR in totality, and, you know, focusing also on your those having a focused effort, so to say, not trying to apply 4IR everywhere, but for instance, now that we're talking about additive manufacturing, to say, how do we use additive manufacturing as a technology for our manufacturing industry, and having that as, you know, a directed focus program that focuses on SMMEs within the manufacturing space. So yes, I quite agree with, you know, your take on this, and thank you very much for your inputs. I think now we're going to move to our question and answer session. We don't have questions. Okay, so it seems that we don't have any questions, but we still have some time. I know that Prof Bofo, you also had additional comments that you said you can make. Now that, you know, we've listened to the conversation from all our panelist members.
Prof is not listening.
Oh, he's here.
Yeah.
Yes.
Hello?
Hi, Prof.
I'm sorry, my connectivity got a little bit bad, so I couldn't get any sound, so I was checking my device.
No, I was just saying we do have a bit more time to continue with the discussion. And now that you've heard from our other panelist members what your thoughts now are, because you did have some additional thoughts that you could contribute to the conversation.
I think from a skills perspective, for me, I think, can you hear me?
Yes, I can hear you, Prof.
Hello?
Yes,
Am I
Prof.
clear?
You are clear.
So I agree with the sentiment that maybe we must go to the industries, understand what the industries are doing, what are their challenges. As Ms. Marule said, that it's important for us to understand what are the issues out there, so that when we curriculate as well, we curriculate aligning to real issues. Because sometimes our curriculums, you know, they are direct of textbooks that are not relevant to us. And I think for me, it's become very important for us to curriculate in a fashion that speaks to the challenges that we have in the country and speaks to the interests that we have as the country. Maybe not just as a country, maybe as the global south in general, because I think sometimes when we think about addressing problems, it's also of strategic and economic significance, not just to think about ourselves, to think about the problems generally in the global south, because that way we're also creating markets for ourselves, and we can actually attract people who can come and get that education, and then they will continuously be our customers moving forward. So I think for me, maybe the Department of Trade, Industry and Competition needs to engage with the Department of Science and Innovation and Department of Education and Training around education on AM, all the way from even, the moment people get into the TVET system, there needs to be qualifications that we are defining around that, and a mass of effort in terms of proper organization and identifying the strategic relevance of specific sectors like the PGMs, which we know that we have a monopoly of in the world, and it's a no-brainer that if there's anyone to develop capability around that and products around that, it is us, because the resource is just in the Northwest, you know. So that's very accessible to us. But how do we work with those resources that are available to beneficiate them locally while it's building these capabilities? But we need that infrastructure within the TVETs, not just from a technology perspective, but also from the skill side, making sure that people are appropriately trained and they're speaking to the needs that the industry has, like Sir Fontaine was saying. I don't know whether that responds to your concern.
Thank you very much, Prof. So we have 5 minutes just to have some final remarks from our panelist members. I will start with Dr. Chigosha. Any final remarks based on the conversation today?
Yes, I think it is very important, as we have discussed in this session, that we do a complete value chain, and as such, from a person coming from the development of powder, it is important that we find a way of locally producing powder to support each and every part of additive manufacturing that wants to spring out of this country.
Okay, thank you very much for that. JP, any final comments?
Thank you, Ntombi. A final thought from me is that, as Aerospace, we are, ever so supportive of SMEs and local suppliers. So the vision is always long-term, that where we can, we walk together and we do it that way. And if Aerospace can lead that front from an aerospace perspective, we'd gladly do so. And where we can contribute in other industries and in academia as we do so, where we can, we will.
Okay. Thank you very much, JP. Ms. Marule, any final comment?
Okay, yes, thank you, Ntombi. And I have two. One is about the skills as well, in terms of HRD and human capital development, and also skills transfer. I want to concur with Prof Bofo to say, one of the things that you see happening in education, the unfortunate thing is that you see it happening a lot in business schools. I mean, if you think about how business schools are operating these days, are kind of developing curriculum that is specific for specific industries. Like I was looking at VET's business school now, they had an internationalization of water resources, whatever. But it's people who are in the water sector that could attend how do you do business in the water sector. And my wish, or my word to people who are developing curriculum, is that we don't necessarily have to see this only with the business schools and as if it's new ideas. Even in engineering schools, we need to kind of see, how do you teach students as they are in third year engineering to say, how do you then create and drive businesses? Because as we are talking, then I'm moving to my next point. We are talking about developing SMMEs. The kind of SMMEs in this space that you are talking about are not, our traditional in South Africa, when we think about them, of people who are doing small things, programming, developing websites. Not necessarily, are actually people who will be producing these components for VW, for Ford. They're going to be the go-to for automotives for a specific part. So you're talking about some people who are really highly educated, but are not in a broad spectrum of manufacturing. But where they are focused, Ford, Germany will come to them and say, we want this particular component because we know this company in South Africa is able to produce it to our specification, and it fits hand in glove with what we do. So in a sense, we have to be very cognizant of the fact that we are not thinking of just developing SMMEs for the fun of it, but they must be highly capable, they must be highly technological and highly productive to then effect efficiency. Yeah, so I thank you. Thank you so much, Ntombi.
Thank you very much for your final words. And Prof Mpofu, you get to wrap this up for us with your final comments on the subject.
Thank you very much, Ntombi, for indulging me. They always say who has the last laugh has the best laugh. I think we've had this conversation. For me, it would be sad if we leave the meeting, and that's the end of everything we're talking about. So I would like, maybe through you, Ntombi, as the chair of this session, that we have a clear way forward, step-by-step process on maybe having a conversation before the year comes to an end on strategies around how we are taking this conversation forward. Because it's great to sit on the Zoom meeting, and but it's sad if these conversations do not precipitate into anything. So there are points that have been raised here around skills. There are points around technology. There are points from the DTIC in terms of the approach that the CSIR needs to be taking. And I also am guilty in that regard, because we are also running a research and innovation center. So the aspects that the department is expressing through Ms. Marule are very important, because it doesn't matter how much you invest in technology. If at the end of the day we are not defining the value chain, then it's a problem. But this thing goes back to all the way what Chigosha was saying around the powders and their development, that entire value chain, if we don't develop it in a strategic way and deliberately make an effort to have to be leading around the space, not just in the region in SADC, but in the continent and in the global south in general, then we're not going to help industries like Aerospace to move forward. And we need more of these Aerospace in the country, not just for local consumption, but for global consumption. Because if the skills are well developed and the products are at the right quality, at the right price, and at the right time, of course, then we will be able to attract the necessary, economic activity with the relevant social impact. So from my side, I want to request through you, Ms. Ntombi, that please kindly maybe find availability of everybody where we can come in a less informal setup and take the conversations forward. And those will be my last remarks. And I think if we move that way, we'll definitely be in the right direction. I think from the University of Technologies, 2 weeks ago, we had the Minister of Higher Education and Training. And he's also speaking to some of the things we're speaking about here, about the fourth industrial revolution, specifically as well, maybe issues around additive manufacturing as a contributor to, beneficiating the opportunities from the fourth industrial revolution. So from our side, the minister has given us a mandate to look at UOTs and TVETs and skills around that, but also saying to us, we mustn't just look at skills, because you can have skills, but if you haven't thought through the value chains, then those skills may not speak to what is really necessary. And it becomes a waste of, state resources that are scarce at the moment and seem to be going to be like this for the long term to medium term. So with this conversation, I think we can come back and come up with proposals that can speak to addressing these challenges, not just within the institutions we represent, but across the country. So thank you very much once again, Dr. Ntombi. I'm looking forward to you facilitating a conversation before the year comes to an end. Thank you.
Okay. Thank you very much, Prof, for your closing remarks. And I do agree, it's important for the conversation to move beyond just this discussion and for us to actually, within our respective fields, come together and come up with, way forward as to how we can assist SMMEs and also what the departments, especially the Department of Trade and Industries requirements are from the CSIR, so that we know from the get-go that we're not doing things in isolation, but we're doing it, integrated together with the department and whatever industry we're going to be targeting. So that then concludes our session. Thank you very much for making time available, and thank you very much to our audience that watched the panel discussion live, and I will definitely set up a meeting with the different topics, things that came out today to say, how do we then move forward from here? Thank you very much.
Thank you.
Thank you, colleagues.
Thank you, Chair.
Thank you.